So this is how-to marine electrical design. It's pretty rare that most of us are going to go through a wholesale rewiring of our boat. I mean, that is going to happen to maybe 1 out of 500 people that have a boat, maybe. Most of us are going to take this and are going to say, Jeff, how should I improve the electrical system on my boat? Right? There's maybe certain parts of it that aren't great or aren't good enough for what you're doing with your boat. And what I'm sharing with you today is the lessons learned from working on so many boats. And I say that with pride because there's nothing I love more, well, other than my partner, than working on boats. The approach that I take with marine electrical is really based on the foundation of an engineer and looking at it systematically. I'm Jeff Cote, for some of you don't know, with Pacific Yacht System, and my life's work is marine electrical systems. That's all I do, that's all I care about, that's all I love. I just love boats. Some of you are going to see that our approach to anything is really sort of standard based, and that's what I'm going to be talking about. Other of you might want to read a little bit more and geek out. We write 2 columns now every month, one in Pacific Yachting for about 8 years now, and another one now in Northwest Yachting. Northwest Yachting is just electronics. It's our hot wire column, and Pacific Yachting does a little bit of both. And yes, I'm a boater as well. I don't just work on boats. I also have a boat like most of us, and it's full of joy and disappointments. It's a journey, right? It's a humbling activity to have, but it's absolutely worthwhile. A little bit about my company. So we started, and I realized when I started working on boats that you can only be good at something if you do it through repetition. Expertise through repetition is my motto. All the things I'm going to share with you is not because I read a book and I think I'm smart. It's because I've lived pain. Pain through the errors that we've done, either ourselves or the errors of others. And that's how you learn, is through experience. And that experience has left us doing, last year alone, this is crazy, 1,000 boats. Now obviously I'm not on 1,000 boats myself. We have a large team, but that collective experience is what I'm sharing with you today. And lastly, on that note, if some of you again want to geek out, we have now about 500,000 views on YouTube. We have over 150 videos, and it's a great way to share our passion for marine electrical and electronics with boaters, not just here in the seminar, but might be some random evening when you're bored watching the tube and you want to watch something else. You can watch, and you've got problems on your boat with electrical, you might be able to glean some information from our experiences. All right, questions going to be throughout. We're going to have the slides also online. When I was doing this presentation in Seattle, I did it twice. People are taking a lot of pictures. No harm with pictures. Hey, if you want to have it right on your phone, but also this is going to be on a PDF online on our website. And then the other thing too that we're going to be talking about today is this concept of conceptual diagrams. What is a conceptual diagram? I asked myself when I was doing my presentation, because I didn't know what I knew what I wanted to do, but I didn't know what it was called. And I Googled and found out that a conceptual diagram is something to convey an idea, but it's not something you're going to build your boat on. Because if I show you too much information, you'd be like, whoa, I'm out. And everyone's going to go for the exits. So conceptual diagrams are a way for us to share information to one another, and it's not how you would wire a boat. So for example, most of these conceptual diagrams do not show the negative. Obviously, all circuits have in and outs, otherwise it would not be a circuit. But all in the conceptual diagrams, I'm showing the positive side, because the positive side is where most of the things are happening in our world, right? The switches are there, the fuses are there. And the other thing too, for some of you, I was asked this a couple times in Seattle, so when I'm sharing with you, we do do-it-yourself services. I work on probably any given week 5 to 10 projects of people around the world, like literally Saudi Arabia, I've got Venezuela, Singapore, every state where people are dreaming about doing their boats, and they're asking for someone in their corner to say, Jeff, I'm doing all the work myself, but I want someone to bounce ideas off. I want someone that's going to tell me what's the right thing to do. Because the one thing none of us have a lot of is time. Time is the rarest of things. And what I'm sharing with you today is this principle of doing it once and doing it right. Don't waste your time just doing work. Think about it. And that's the important lesson I'm trying to share with you here today, is the concept of imagining what you're going to do so that when you do physically take the time to build it, you only do it once. There's nothing more disheartening, and I can tell you, I've met hundreds of boaters that have gone down that path where they get busy to do something, and later on I come on board and I'm giving them this heartening news that what they did was wrong. They have to rip it out, start over again. They go through the well of despair. Okay? You want to avoid that well of despair, so plan it out. Okay? It's not very fulfilling to do a plan, but you're going to get a lot of satisfaction when it's done right. Let's not freak out, people, but that is what a typical boat electrical system looks like. I'm very proud of this diagram, I have to say. It was a late night. And the biggest thing about this, and this is key, and ignore this to your peril. I ignored it for years, not knowing what I didn't know. And there is this concept that is rarely...
Sorry, did you say all this will be PDF?
Oh, everything's on PDF on the web. You can take pictures, but it's a PDF. I'm all about sharing. All about sharing. All right? So this incredible concept is called the unswitched distribution and the switched distribution. It's very, very, very important that you do not neglect this concept. Otherwise, welcome to a world of magic. Your boat is going to be full of magic. What I love about electrical is that electrical is deterministic. Electrical is very predictable if it's done right. But if you do it sort of a MacGyver way, things get weird. They're not weird in the moment, they're weird later on, permutations. And that's where you start getting very anxious and nervous about your boat's electrical system, and it might stop you from doing what you want to do, which is out boating, and having a system that you can rely on. So the concept of unswitched distribution is where all these connections are before your battery switch, and then you have connections after the battery switch. So chargers, alternators, solar controllers, battery isolators, battery combiners, wind turbines, methanol fuel cell, bilge pumps, carbon dioxide, all these loads are what are called unswitched distribution. They're all fused, but they're unswitched. And then you have switch distribution, which is DC panels, maybe an inverter only, windlass, thrusters, fuse blocks. These are switch distribution. And we're going to be going through all of this today, hammering that point of the concept of switch and unswitched distribution. I know all these words sound boring, but they matter. Okay, everything, all in electricity, it's a detail-oriented business. If you don't like details, electrical's not for you. Question?
The inverter charger, where would it go?
It would go unswitched because it's got a charger.
But did you say you should have a service disconnect?
I'll talk about that later. Absolutely. This is a conceptual diagram for an AC system on your boat. Doesn't matter how big the boat is. I have the honor of working on all sorts of boats. It could be a 20-footer. It could be a 150-footer. Everything in between, it all looks like this. Doesn't matter, it's just more of the same. On one of the boats we're working right now, an 85-footer, it probably has 100 AC circuits. It's crazy. Off the wall. But at the end of the day, it's not hard. It's just more of the same. So here's what's the concept. You're going to have on a boat what are called AC panel, which are non-inverter loads. Non-inverter loads are going to be a hot water, a battery charger, and then you're going to have off of that what is called inverter circuits, and that's going to be AC pass-through or inverter loads right here. And those might be your microwave, might be a fridge, might be AC outlets. You'll see that on more modern boats where inverters existed when they built the boat. And I was on a client boat, brought his boat from Tacoma. We have a lot of Americans that are bringing their boat up here now for us to work on. And this owner literally had a panel which was like, it literally said those things. It was AC inverter. All the inverter loads were a different sub-panel. Now, some of us don't have new boats. Most of us don't. And so your panel might not be divided like that on the front. But if it's wired properly, the back is going to be wired like this. So you're going to have certain loads that can only run off the inverter, and certain loads that will never run off the inverter. For example, a hot water heater can never, ever, ever run off an inverter. You can do it, but you're going to lose your batteries in 2 hours. It's sort of like creating heat from burning bills. It's doable. You can do it, but nobody in their right mind would ever create heat from batteries. It's just, there's not enough big battery bank out there. It doesn't matter if it's lithium. I don't care how much money you have. Nobody creates heat from batteries. No one. Okay, so as a starting point, this is the boring part. The boring part is you've got to start creating requirements. Here at the boat show, I get people all the time telling me, Jeff, how much to do this? And that this is an electrical system. Well, Emily, that's pretty open-ended. How much for a house? How much for a kitchen? Well, it depends. What kind of house do you have? So the key is to start with your requirements. Think about what you're doing on your boat. Whatever you're doing, you've got to start having a plan. And I tell people all the time, very few things in life turn out great without a plan. Very few. Plans are what actually make things turn out to be amazing. Okay, so first thing you got to think about as a boater is, what are all your AC and DC loads on board your boat? You got to start knowing that. That's very important for sizing a panel, for sizing all these different things. You got to have a sense of what the requirements of your system are going to be. It might be water pumps. You might decide to have a large inverter. What are you going to do? You're going to run an S-bar heater, or you're going to run a hurricane heater, or you're going to have lots of chart plotters, are you going to be running an autopilot all the time? What are you going to be doing? You have to start thinking, what are the things I'm going to be doing electrically on my boat? And you've got to start putting that on a piece of paper. The other thing too that's super important and very hard to do without a battery monitor is you need to know what your daily amp hour consumption is. To some of you that might sound Greek, it doesn't make sense, but let me tell you, there is nothing more beautiful than knowing what your daily amp hour consumption is. That is knowing, it's like knowing your burn rate. Nobody can plan your retirement without knowing what your burn rate is. If you're going up to a retirement specialist and you say, I don't know how much money I spend a year, but how much do I need to save for my retirement? They're going to look at you like, well, how am I going to work with you if you don't know how much money you need? We need to know what your daily amp hour consumption is. Are you using 100 amp hours a day? Are you using 75? Or are you using 800? I need to know that number to start figuring out everything on your boat. If you don't know what that answer is, after you can come and ask me questions. I'll be able to suss it out just by figuring out. Or you have a battery monitor. If you have a battery monitor, you'll know what your daily amp hour consumption is. And lastly, and very importantly, how frequently will you be able to recharge your batteries on your boat? Are you going to be staying at anchor for a week and not run the engine, and you don't have solar, don't have a methanol fuel cell? Well, how are you going to do recharge? The frequency, how often do you get a paycheck, tells you how much money you need between paychecks, right? Some of us are able to run a battery charger through a generator every 12 hours. That's great for people that have generators. Some of us are sailors and we want to be at an anchor for 3 days without running the engine and an alternator. How do you do that? That frequency of recharging affects dramatically the type of electrical system you're going to have in your boat. And I want to say, and this is the most disconcerting thing for all of us, the reality is there is no such thing as a perfect electrical system for everyone. All of us use our boats differently, and there is no one-size-fits-all electrical system for any of us. Every one of us are going to have an electrical system that is tailored to our boat, our budgets, and what we do with the boat. That's why it's so hard, right? It's custom. It's tailored to you. Let's talk a little bit about batteries. By the way, I want to emphasize, I could make, literally no joke, an 8-hour presentation on batteries and I would skim the surface. I just barely start. I have 1-hour presentations just on batteries, and that's sort of like high level. So if you're curious about all of these topics, there's way more information on our website. We've written hundreds and hundreds and thousands of articles now. So this is sort of a taste, okay? So just remember, we're not going to be pros about marine electrical after this, but it gives you enough to be dangerous so you can know what you don't know and you can be curious to find more about it. Marine batteries come in all different sizes and shapes. You can see that, different chemistries. It's crazy. Yesterday, I think, or the day before, I did a 1-hour presentation just on batteries, and that's sort of just an intro. That's also going to be online, by the way. We're going to post that presentation for some of you that missed that. It's going to be posted online and it's a YouTube video. Every year we're actually doing YouTube videos of all these presentations. So if you buy a battery, you're going to have to figure out what kind of battery you're buying. Is it a starter battery, deep cycle battery, or dual purpose battery? And then also talking about what kind of battery chemistry are you doing? Are you going to do flooded lead acid, gel lead acid, AGM lead acid, absorbed glass mat, fiberglass, foam-based core AGM? Or are you going to do maybe perhaps a lithium? There's a battery for everyone. Batteries are built for a purpose, different budgets. Again, it all factors in. Very important. The battery is maybe the core of your electrical system on a boat. Okay, you've got to spend a lot of time thinking about what's right for you. And if you have frustrating battery experiences where batteries are dying all the time, they're short life, that means that your batteries are not they're not for you. You need to find maybe different chemistry, different battery size, different charging regimen for your batteries. Someone was coming in the booth this morning and saying to me, said, Jeff, do you have a chart that summarizes the differences between a flooded lead acid battery, a lead acid gel or AGM, and a foam based core? This is pretty much the three major types of batteries that we deal with. They're all lead acid batteries, by the way. And here I emphasize the price difference, the battery life that you're going to have. You're going to have 4 times the battery life with a Firefly AGM battery. And here's the kicker, here's the really important thing. This is why I love Firefly so much, is that you can have 65% of the battery is usable, meaning it's like a workhorse. With that same battery, it's all about energy density, usable energy density. That's why it's worth thinking about as a contender an AGM battery on your boat, especially if you want to save space or volume. Really important. And notice that this battery here, this Firefly AGM, basically almost doesn't age. It's crazy. It's like 3,600 cycles at 50% depth of discharge. It's like living to 1,500 years. It's not infinity, but 1,500 years is a hell of a good run. Okay? I joke around with some owners. I'm like, you know what? This is going to be your family heirloom. To your daughter, you're going to give jewelry. To your son, maybe. You'll say, hey, Johnny, here's the batteries. Use them on your boat. Love them as much as I did. That's how many cycles you get out of a Firefly AGM battery. Okay? It's crazy. These are installs of Firefly batteries that we've done. Okay, here's some tips. Really important. So when you're doing batteries on board, you're going to want to always make sure that your batteries evenly charge and discharge, right? That's really important. Sort of like your winter tires or in a car, you want to have even rotation, wear and tear. That's why they rotate your tires. That rotation is the even charge and discharge of the battery bank. You do that by having positive and negative terminals or connections at the opposite ends of the battery. Also, make sure your batteries are in leak-proof containers. That's a big, honestly, probably 75% of you don't have that. Unfortunately, batteries are often installed in non-leak-proof containers. People drill holes in the bottom of them. It happens to all of us. It's unfortunate, but it's a reality. You can get away with that if you've got AGM, but if you have a flooded lead acid battery, your battery box is a container for liquid. It's not to hold the battery in place. It's to hold the electrolyte that will come out of the battery, and it will. No matter what you do, it will happen. Especially as the battery ages, batteries do vent electrical sulfuric acid. And also make sure that all the leads are fused. When I was teaching in Calgary for Blue Water, I had an engineer in the room, and the engineer was working in the oil sands, and he was reminding me, he's like, you know, Jeff, on land, the code is a minimum. That's it. It's not what you shoot for, it's the bare minimum. Here on the water, it's almost, the world is upside down. People consider the code to be an ideal that they'll never achieve. Well, that's just ridiculous. It's the code. You kind of go in that direction, and if you don't get there, well, at least you tried. But that's insane. It's craziness. If you did that on land, it would be criminal. Someone loses their life, they'd come after you for everything. On the water, it's your choice. That's madness. So as a boat owner, the most disconcerting thing is out there, and I've had this happen on my boat, and this is how I'm in this business, is that your previous owner decided what his risk tolerance was, and you as an owner are living with that on your boat. Because boats today, once they leave the factory, it's the Wild West. And some people have a very, very high risk tolerance. And those owners make decisions on their boat, and then you assume as the next owner that everything was done up to code, but that is disconcerting and real, is that probably a lot of things on your boat are extremely unsafe because someone wanted to take a shortcut, either for time or money. And they're like, well, don't worry about it. You know, I hear this all the time. My gasoline engine will never leak fuel, and hence it's okay for me to not have ignition protected devices in my engine room. I don't worry about it because I'll never have a leak in my engine room. Good for him. Good for him. It's a simple world for him. But for the rest of us, I would not sleep on a flammable couch and be a smoker. I wouldn't. I'm like, no, I'd like to have my couch non-flammable, please. I do not want to self-ignite in the middle of the night. It's not part of my dream. So the code is rarely used. Make sure you have fused battery leads on all your battery connections. All right, now we're going to get into the meat of things. Batteries are good, right? They store energy. But I remember all these stories that my mom used to tell me because she's a businesswoman. She's sort of my little coach. She's awesome. She remember telling me I'd always ask for money. She says, I can't give you money. Money is easy to give. You got to earn it. And it's easy to have battery power on your boat, but at one point you're going to run out. Battery power is just a storage. What are you going to do to generate energy to put it back into the batteries, right? Because at one point, unless you go out just for a day, you're going to run out of batteries. So the next thing we're going to be talking about is how do you go about generating all that power on a boat? Remember this, and this is often overlooked, probably very overlooked. Batteries need to be charged at a minimum of 10% of battery capacity. Minimum of 10% of battery capacity. If you don't charge it at that rate, your batteries will die prematurely, and you'll be unlucky. You'll be one of those boaters that complains that their battery life is half or a third of what it should be. And that generally is because your charger is not as big as it should be. If you don't charge at the right rate of charge, you will lose your battery capacity. Every single boat manufacturer I've ever been on, ever, all time, every single one, the battery charger is always 10% of battery capacity. All the engineers around the world know this universal truth. The moment the boat leaves the factory and you double, triple, quadruple your battery bank size, the charger is not sized appropriately for the battery bank that you put on your boat.
Sorry, Jeff. Does that mean you have, let's say you have 3 200 amp hour batteries. Does that equal 600 amp hours?
And your charge rates.
You got a 10% of that, so you got to dump to load charge that 60 amps of power.
That's correct. So the question is, if I have a 600 amp hour battery bank, right, what is going to be the minimum charge rate that I have to do at bulk? The minimum charge rate you have to do at bulk is 60 amps. You don't have to do it. It's like I can eat McDonald's every day, but my life expectancy won't be the same. So you can choose to not do it, but also realize that then your battery bank will not last as long as it could have. So the charge rate is very important under bulk. It's not about time. You need to have enough pressure to re-energize the whole of the battery. I could talk about that for 2 hours. Go down the rabbit hole together. We'd geek out, but for the sake, I don't want everyone to be running for the exits, so we're going to just leave it at what. The why takes forever. The what is easy. It's like the Coles Notes. All right, so let's talk about a charger here. We've got a charger, a battery charger. Notice how a battery charger is powered by AC, right? So battery charger is not powered by an alternator. They're powered either by a generator that creates AC or by shore power that creates AC, right? That you have AC. And then that battery charger can have multiple outputs. And notice how there's fuses. And notice how the house battery bank has an unswitched distribution with a fuse. Very important. That's basically the concept. You're going to have to, obviously, and here I talk, size the charger to be minimum of 10. Fuse the battery leads, which is really, really important. Honestly, 90% of you don't have fused battery leads. People don't understand. It just doesn't get done. They're like, whatever. Engineers, they make up stuff. It's not required. And the other thing that's very disconcerting, and this is where the magic happens, if your battery charger is connected to the switch side of the circuit, right? Like when you turn the battery switch off, your charger is connected to the loads and not the battery, you are in a world of pain. Your boat is full of magic. Get calls all the time. Think about this concept. You shut off the water main on your home. It's closed. There is no more water coming inside your house. You go to the faucet and you open the faucet and water's coming out. Now that is magic, right? How can you disconnect a battery from your loads and your panel is illuminated, your VHF works, your water pump works, and your battery is not connected? That is very dangerous. That is because your battery charger, your alternator, your solar panels, your wind turbine, your methanol fuel cell are switched. You cannot have that. Black and white. So very careful of that. So it's got to be unswitched. Here's an example of an inverter charger. Notice how there's an inverter service disconnect here. And that was your question. It needs to absolutely black and white be to an unswitched distribution. It has to have its own dedicated switch. By the way, I almost high-five myself. I should have little firecrackers and like a little hat. When I see an inverter properly wired on a boat, which is maybe 1 out of 100, I'm sort of have a little moment. I'm like, oh my God, somebody read the manual. That's awesome. This is great. And I start having hope. I'm like, there is hope. People do read the manual. Literally 99% of you here in the room do not have an inverter that is properly installed. And the reason is simple. The manual is almost, not a centimeter, but about 7 mils, 8 mils thick, about 80 to 120 pages. And any self-respecting man is going to see that and say to themselves, well, this is ridiculous. I'm not going to read any of this. This is too much. And so they just do. And that's the reality. And inverters generally don't have fuses, don't have an inverter service disconnect. Big problem. They have the wrong fuse. They don't put a neutral bus. I mean, that's like 1 out of 200 boats have that. They don't have a ground wire size. That's like not even 1 out of 200. Every boat has an undersized wire, every single one. And these things matter, by the way, because an inverter is a very dangerous device. Very, very dangerous device. You've got large AC wiring coming in there, right? You could have 30 amps, 50 amps going in there. And you could have up to 300, 400 amps of DC amps going through that device. This is a big device. This can draw a lot of power, create a lot of power. That device is probably the most power-hungry device other than a thruster on your boat. And it could be running for 20 minutes, 10 minutes, 5 minutes. It's running all the time. It's always connected. Inverters are very badly wired, unfortunately. So these are the different things you got to look for. Here I talk about the location of the inverter. Inverters are inverter chargers for the most part, and I see them installed in gasoline engine rooms all the time. They are non-ignition protected devices. The boat builder went to great lengths and costs to make a gasoline engine room ignited protection or ignition protected, and I see people that are swapping chargers for inverter chargers, and then they have a non-ignition protected device in their engine room. Very critical. You can't have that. It's got to be in a vapor-proof location outside of a gasoline engine room. But you can put it in a diesel engine room, no problem, but not a gasoline one. Okay, here we're going to talk about alternator wiring. 99.99% of all boats, all cars, all machinery on Earth is wired like this. You got an alternator, daisy chained to the starter solenoid post right here, to a switch to a battery. I remember when I bought my boat in 2006 on my inaugural trip, May long weekend, I wasn't sure if my alternator was working. So with a lot of bravado and confidence, I was a different man back then. Very different man. I'm a changed man now. I went downstairs and I said, babes, I got this. Let me test if my alternator works or not. And I did the very thing which was labeled underneath the switch. By the way, this was a humbling experience. And I turned the battery switch on and off. I was like, I'm not sure if it works or not. And by the process that did that, I did blow up my alternator, by the way. That did blow up. I don't know if it was blown up before, but I can guarantee you, when I turned the switch off, my alternator blew. And I remember that feeling. I felt so special. My partner was really nice about it. She knew I was in pain. We were stuck at the dock for 7 days because of that error on a 2-week trip. My brother had flown out. My best friend had flown out. His girlfriend had flown out. 2 weeks, at the time we all had only 2 weeks of vacation, they spent 1 week at the dock. Why? Because I didn't understand what was going on. The switch said, it literally is, this little small print here says, don't turn off while engine is running. But with a lot of bravado, I just did. And so the lesson is, you got to educate yourself, and that's what we're all doing here in the room, right? Educating ourselves to make our boat experiences less painful. And this is basically what an alternator wiring should look like. Means that your alternator is directly connected to the battery, unswitched. That's how it should be. I didn't invent this. Nigel did. A bunch of people did. I just think it's a great idea. It's phenomenal. You want to have an unswitched connection between your alternator. So if you have a high output alternator with an external regulator, we're going to try to get the alternator output directly connected via fuse to the battery switch, the house battery. I see this all the time. People are changing their alternators, but they're hoping that the wire that is there for a 55 amp alternator is going to handle a 160 amp alternator. I've seen wires melt so much that the jacket is completely gone. It melted. It's a bare wire just hanging in thin air. And that's how hot oh, by the way, the alternator doesn't output very well though. They don't understand why their 150 or 120 amp alternator is not outputting what it should. And the limiting factor, which luckily hasn't blown yet, was the wire. It was a 10 gauge wire that can only handle 30 amps. So you've got to make sure, and I've seen this all the time, make sure that your alternator is sized to handle the wire between the alternator and the battery. Because on most boats, to be honest, we have only a 10 gauge wire between the alternator and that starter solenoid post. You could have a 55 amp alternator, it's a tiny little wire. So if you don't change that wire and you change your alternator, you're in a world of pain. I tell this all the time, you know, now we're about 15 people in our company. I say rule number one, always see rule number one, nothing's ever easy. Don't ever walk on a boat and think this is going to be easy. If it's easy, you overlook something and you have no idea what you're getting yourself into. Nothing is ever, ever easy. There's always tons of things that need to happen to make anything happen. You change one thing, you have to worry about other things all around it. You can't just swap a piece and hope that everything else is going to work. Solar. Big fan of solar. Done probably about 500 systems now. Did our boat in 2007. Essential that you're going to have what's called a controller to control the solar output down to your batteries, right? Because your solar could be outputting 20 volts, 40 volts, 60 volts, and your batteries don't want 60 volts. Sometimes they want only 13.3 volts. Sometimes they want 14.4 volts. Depends. Are they hungry? Are they overcharged? They want to be float. A controller is going to allow that solar panel to be smart and to not overcharge the batteries. That's why every single solar panel needs to have a controller between the panel and the batteries. We have this set up in the booth. If you're curious, you can see both. Literally, we have this exact setup in the booth, not a coincidence, where we have two solar panels wired in series, and then you have only two wires going to the controller, and then two from the controller to the batteries. But notice how I have a fuse here. Very important to have a fuse at the battery. Very, very, very critical. For some of you that are considering solar.
Sorry, Jeff.
Yeah, go ahead, Josh.
Quick question. With both the schematic there and the alternator, if your fuse blows, then what happens to either your solar panel or your alternator?
Yeah, so what happens if you blow this fuse for whatever reason? Well, then the solar panels are not going to be charging your batteries. Nothing happens bad at the solar panels. They're just disconnected from the batteries. So your solar panels are not going to be giving you any output. They're going to be connected to the controller, but the controller is not connected to the battery. It doesn't have power to even turn itself on, and so nothing happens. It's basically having what's called an open circuit.
What about for the alternator? If that fuse?
Yeah, if the fuse blows while the alternator is running, then you're going to lose your alternator, but it's better losing an alternator than catching your boat on fire. Because if the fuse blew, that means you had a dead short. If you have a dead short, you're one step away for running for exits. And if a cable, a 2-aught cable, a 1-aught cable catches on, melts because of a dead short, no amount of fire extinguisher is going to solve you this problem. You're out for the exits. A dead short on a 1-aught or 2-aught is the end of the world. It's like a dynamite exploding in your living room. There's nothing you can do for that. Question?
What device on a boat will determine if the alternator is charging the battery or the generator charger is charging the battery or the short cord charger is charging the battery? Meaning that when you're running, if you have the alternator turning, which is charging the battery,
Yeah.
your generator
Yeah, so this is a good question, actually. There's no such thing as a bad question. Truly isn't. So we all have multiple ways of charging our batteries, right? You could have solar. You could have an alternator. You could have a battery charger. You could have a wind turbine. You could have a methanol fuel cell. Let's talk about my boat. Show the extreme situations that I do on my boat. I have an alternator, high output alternator with an external regulator. I have a battery charger, 100 amp battery charger. I have 6 solar panels with 6 controllers because I like redundancy and I like efficiency. And I have a methanol fuel cell. I have 9 devices that charges my battery. I could be connected to the dock. Methanol fuel cell is working. Solar, beautiful sunny days. 6 controllers are online. I started my engine and I'm connected to shore power. Every single one of my devices are smart devices and they're all voltage regulated. A lot of them are going to go offline and they're going to say, I don't need to do anything. Someone's already got it. And if the batteries are full, they're all going to be looking at the voltage. They're all going to be regulating themselves based on voltage. And I could have 20. I have 9. I mean, that's a lot. And I have never had a problem, never overcharged a battery. All of them are voltage regulated. They don't add upon themselves. They're all smart devices. If we had this conversation in 1975, we'd have a problem. There was no such thing as smart battery chargers then, and you would literally be in a world of pain. But nowadays, with voltage regulation, and that's how all of them do it, you can have multiple sources charge one thing, and the smartest one is probably going to be offline first or online first, depending on how fast it pulses. This is a conversation that could last 2 hours. We could go in a rabbit hole together. I'm not sure everyone would want to join me, so I'm going to leave it offline, but don't worry, you can, as long as you have smart charging devices, you can have them run concurrently. People do that all the time. All the time. I mean, how many of my boaters have an alternator running an engine, right, charging the batteries when they have solar panels connected? How many? Most of them, right? It's not uncommon. They connect to shore power, the battery charger kicks in, and it's sunny. 2 sources of power. They run the generator, run the charger at the same time. Not uncommon. It was something to worry about in the 70s, but in 2018, it's all fine. So if you're wondering about sizing a solar panel for your boat, the rule, there's a long formula. Sure, some people are going to geek out, and I have people that say, oh, show me the long formula. I got it, we can play with it, but why? There's a short one, why don't we do the short one? The short one here in the Pacific Northwest is, if you have a 100-watt solar panel, it's going to give you a daily output of 25 amp hours a day. That's pretty easy. Factor 4. Divide by 4. So you're going to get about 25 amp hours of daily solar output. An amp hour is a unit, it's a quantity, like a kilogram, a kilometer. An amp, which is confusing, is a rate, the rate at which something is going. So an amp is speed, really, and an amp hour is a quantity. So if you go 100 kilometers an hour, after 1 hour, you've traveled 100 kilometers. Same thing with an amp hour. If you had a charger that was running at 25 amps for 1 hour, you would have created 25 amp hours of energy. What's confusing about an amp, and I've noticed this over time, is it's a word that does not say time in it. And then people think it's a quantity. They think it's something, but it's instantaneous. It's speed. It's like wind, 10 kilometers an hour, right? It has nothing to do with distance, right? So an amp hour is a quantity. Amp hours are the rate at which something is going. Same thing with watts. That's why there's something called the watt hour. So if you've got a solar panel or you're thinking about doing it, you've got to make sure that you choose an MPPT controller that's sized for your battery voltage. So if you have a 24-volt boat, your controller is not going to be a normal controller. It needs to be a controller that is sized for a 24-volt battery bank. You want to make sure that you have the right battery chemistries, very important, especially if you have AGM or you might have Firefly or lithium. And you have to fuse each panel and each individual load at the battery, at that positive unswitched distribution. Okay, next, we're going to talk about methanol fuel cell. I have one on my boat. We have them in the booth upstairs. This is basically a device that creates It's sort of like a methanol-powered battery charger. If you buy a unit that says 210 on it, for instance, you're going to be outputting 210 amp hours a day. So that means over a 24-hour period, it's outputting about 8.4 amps every hour, continuously up to a maximum of about 210 amp hours a day. But notice what I did here, and this is very important because some people are buying these and installing themselves. It's very important that you have a methanol fuel cell, again, because it's a charger connected to your unswitched distribution. Very, very important. And notice that a methanol fuel cell has 4 wires connected to it. Here I'm just showing you the positives. It has a voltage sense and it has an output, and that's done on a different wire. It's very important. Regulators do the same thing. Another thing too is when we actually are designing systems, we're actually putting these on some boats. I did a boat in Yukon. I've never saw the boat. I'm just doing a design package, setting stuff up, and the owner's installing himself. But what I always remind people is you're going to need some sort of ventilation because this emits heat. It's like anything, a charger, an inverter charger, anything that creates energy is going to emit some heat. And it also emits distilled water. So if you have flooded lead acid batteries, you can actually take that distilled water and actually top off your batteries. All right, this is the hard part because it's so promising and so hard. This is why I love this stuff. This stuff gets me, oh, I love it. You never know what sort of magic you're going to find with battery combiners. They seem like, I was so excited about those things, and then we start seeing the reality, and the world is full of problems. I had another owner remind me of that. He's like, Jeff, he says, you know what I like? I said, what is that? He says, I'm an engineer, and he has a big engineering company. He says, I like going out in the field. I'm a field engineer. I'm like thinking, field engineer? Yeah, he says, that's where the real world happens. We are here in the lab, in the office, putting things on paper. But the real world happens when you put it on in the field and see what happens. And I was realizing, I'm like, oh, that's what I love too. The difference between what I think is going to work and what actually is going to work. And because we get invited on so many of your boats to troubleshoot problems, I get to realize what are the implications of our choices. And so the collective out of that, and this is where this is probably one of the most complicated devices that you could ever install on your boat, not realizing the pitfalls of it. This is called a battery combiner. A lot of you will have that device on your boat. It's actually an inexpensive device. I don't know, 120, 140 bucks. And what it does is it puts your batteries in parallel automatically whenever there's a charging voltage. It's sort of a replacement for, back in the day, boaters used to go off, one, both, all, two, and they would turn the switch to all whenever the alternator would be running. And then what manufacturers like Blue Seas has one, BP has one, Mastervolt, everyone has one, right? Xantrax have it. They call it VSRs, voltage sense relays. They call them automatic combiner relays. They call it Echo Charge. Everyone builds one. And notice what I demonstrated here. Remember, a wire obviously does not have a direction. It's a pipe, right? But what I'm trying to show with the arrows here is that an automatic combiner relay or a battery combiner is going to allow current to go both from here to here, from house to engine, or from engine to house. So for instance, let's look at this. If you've got an alternator charging your engine battery goes to 13.3 volts on a 12-volt system. Combiner sees 13.3, says, oh, great, land of plenty. Let's start sharing, right? Great. Start sharing, goes to unswitched distribution. Unswitched distribution gets power. Power goes to your house battery. Great. Here's the reality. You're thinking, oh, I have an alternator that's only 90 amps. This fuse is 120. This fuse is 120. This is a 90 amp alternator. There's never going to be more than 90 amps going this way. Then you're looking at your battery chart. Your inverter charger does maybe 100 amps. You're like, oh, perfect. That fuse will never blow. Your solar only does 10 amps. You're like, perfect. Fuel cell does 8. Perfect. Wind turbine, 20. 120 here, 120 here. My fuse will never nuisance trip. If you put a house battery that is seriously discharged in parallel with a fully charged engine battery, think about a dam. A dam is 2 levels of water at different levels, right? You got something that's 100 feet tall, 300, and you got a river at the bottom. That turbine is turning because there is a potential difference, right? And people use water as a great analogy all the time. The bigger the delta between one side and the other side means that you can have a crazy amount of amperage coming through this device. But this device is rated only for 120. So you can only put a maximum of 120 amp fuse here. I see those fuses blowing all the time. And the problem is this is not Star Trek. There's not a little computer here telling you on a dash that a fuse blew. You have to realize that the fuse blew. And the only way you would know that is if you know what's going on in your boat. So I get called on boats all the time where, for example, this is a thruster battery and it's completely dead. It's completely dead because that fuse blew and they never knew about it. And 4 months later, the battery's completely dead and they have to change it. That's the problem with a battery combiner. It's easy and great until something falls apart. So when you get one, you've got to make sure you've got the right application. You need to make sure that you choose the right fuse size for the application. You need to make sure it's not connected after a switch, but before a switch. And you should, they're not going to tell you this when you buy it, by the way, but it should be sized for about similar battery banks. This device is a miracle device. This is called a battery isolator. And a battery isolator is a device that allows your alternator input to go to 2 different battery banks, but neither of these battery banks will ever see one another. There's no parallel connection here. It goes in, and then it goes sort of like a Y valve, but gated. They used to be called diode combiners, but diode combiners had a big problem. You would lose about 70% of the energy for that automation. 70%. If you had a 100 amp alternator, you would lose 70 amps out of that alternator for that automation. These devices only make you lose about 1, 2, 3%. And it's a way for you, and all of us have this problem. Like on my boat, I have a single alternator, and I want to charge my engine battery, I want to charge my house battery. How do I do that? I bring my alternator output wire to this device, and then I take this device and I send it to engine battery and house battery via the unswitched distribution. This will never cause nuisance tripping, ever. Because the only thing that feeds it is the alternator. The alternator will never feed more than what it's rated at. There's no such thing as an alternator that's 100 amps and it fails to 300. You never get more than what you started with. If it's an alternator rated for 100, it's only ever going to rate 100 or less. It will never do suddenly 300 amps. So you fuse this here for 100 amps, and you'll never have nuisance tripping. So this is a really, really good device. We use it all the time. I have it in my booth. It's one of my favorite things. You got to make sure that you size this battery isolator so it doesn't trip. You don't ever want nuisance tripping. That's very important. You also want to make sure that your alternator cable is big enough to handle the amperage coming from that alternator. Very important. And some models require ignition power so they know when you're actually running your engine. The ones we're using from Victron don't. So with that, I've got 10 minutes. Perfect. I'm going to open the floor to questions on what we just talked about. Anybody want to ask a question about electrical? Go ahead.
I don't know if we touched on this, but I recently had the bronze off my boat props snap off, and I was told there was electrolysis happening on the boat. What can be causing that?
So the question is, this gentleman had the props fall off or break off?
I had a blade fall.
Yeah, so he had one of their propellers get damaged pretty severely, and he was asking me what can be done to prevent underwater corrosion. And this is not galvanic corrosion, which you can't really stop. This is straight current corrosion, and there's really 2 ways. First step is putting a galvanic isolator on board. By the way, everyone agrees it's universal, black and white, that it's a good idea to have one. The only reason you don't have one is cost. Easy to install. That's the first step. galvanic isolator. They're about, I don't know, 400, 450 for a 30 amp model. Fail safe. Don't ever buy a non-fail safe version. And the other thing, which is way better, and everyone should have one. Everyone agrees everyone should have one. But because of space, weight, and cost, we don't. And those are called isolation transformers. There is no downside to an isolation transformer other than its price, its weight. Some of them weigh 300 pounds. And its volume. Every boat wants one. Unfortunately, many boats simply can't put one on. There's just no place for it. So an isolation transformer is an amazing thing. It solves all that pain. And generally, I get to install one all the time to the owners that have that problem. I get about those calls. I get about 10, 20 in the summer. And the pain is insane. Some people lose $50,000 worth of underwater metals underneath their boat. Their engines are like, the props are gone. The stainless shaft is gone. It's just ridiculous. And they're like, I need an isolation transformer. And that's why all the builders like Fleming, Grand Banks, Sea Rays, I don't know, it could be a Silverton, all those big boats above 40 feet are all going to have one stock. They just do. It's a great idea. Yeah, just what you had a question. I'll come. Yeah, go ahead.
You talked about smart chargers or smart something.
Yeah, smart battery chargers.
Right.
Yeah.
How do you know if you've got smart? Maybe my stuff's too old.
Yeah, that's a great question. How do you know if your battery charger isn't smart? Luckily, non-smart battery chargers were invented or manufactured in the 70s. And in the 70s, unfortunately, the world was probably led by engineers, and there's no designers running those companies, and they look ancient and ugly. So if you have a battery charger that looks from an unknown world, you're like, why is it so hideous? That's because an engineer built it. And most engineers are not really worried about aesthetics. Because as long as it works, why does it need to be pretty? So if your battery charger looks absolutely hideous, or it doesn't say smart on it, because someone who's smart is going to brag about something being smart, right? But engineers are like, well, it's so good, why would I need to tell them? So those are ferro-resonant chargers, and those are chargers you want to get out of your boat. Resonant charger, the non-smart chargers. I got 2 more minutes. I had a question over here, and I'll come over here. Yes?
We're having solar put on the boat, and I expected that I wanted as much solar as I could possibly get on, because you can always consume the power. I was told by him that basically if you have too much, and your batteries are charged, and your panels are in full sun, then that's bad for the panels. Is that true?
Absolutely not. The question is, if you've got a solar array that's really big and your batteries are full, is it bad for the panels because they're not working and they're not creating? No, they're going to open the circuit. That's all it does. By the way, your controller constantly opens and closes that circuit all the time. It's like, it's called pulsing. You see it so fast that you don't see it. It's like a movie. You know, there's no such thing as a continuous stream of images. You're changing the images so quickly that you don't notice it. My solar array is awesome. Okay? And in the summer, in July and maybe June, it's too much. And I don't need to turn anything off. But it's sized perfectly for April, May, late August, and September. I have 450 watts on a 36-foot sailboat. It's awesome. I don't ever connect to shore power, never worry about anything. I sail destination to destination, and everything runs. It's great. And my solar panels have been on my boat for 7 years, never given me any grief. So that is a fallacy. Last question, and then I'm going to give the floor to the next talker. For your isolation transformer? Oh, it's simple. It's the size of the amperage coming into your boat. So if you're going to literally, it's going to be like 220 volts, 50 amps. That's how you choose your isolation transformer. It's the amps coming in from shore power. That's how you choose that. With that, I'm going to leave the floor. I want to thank you everyone for being here and geeking out with me today. If you've got more questions, we're doing a DIY garage, and then I'll be upstairs for the rest of the show. Thank you everyone. Appreciate it.